Hello, in this video I'm going to talk about resolving vectors. Actually, resolving vector is just a bombastic way of saying that we want to split a vector into two components. In scalars, it's like saying I want to split the number 5 into 2 plus 3. So with vectors, I can say that I want to split this vector v into two components, v1 plus v2. Usually, we will resolve a vectors into two components which are perpendicular to each other. For example, this vector v here can be resolved into its horizontal and vertical components. To do that, we just imagine a rectangle with sides horizontal and vertical. And the size of the rectangle is such that the diagonal of the rectangle fits the vector v that we are trying to resolve. So now you can see this right-angled triangle here. So the vector we are trying to resolve is the hypotenuse of the triangle. So the horizontal component is on the adjacent side of this right-angled triangle, so its magnitude is going to be v cosine theta. The vertical component lies on the opposite side of the right-angled triangle when viewed from this angle here, so its magnitude is going to be v sine theta. The same vector v can be resolved in other directions. For example, we may want to resolve it into two components along these two perpendicular directions. So we imagine a rectangle whose sides are parallel to these two directions here. Notice the sides are in the directions that we want to resolve the vector into. So again, the vector that we are trying to resolve must be the hypotenuse of the right-angled triangle. And so this component here lies on the adjacent side, therefore its magnitude is v cosine theta. This component here is the opposite side, so its magnitude is v sine theta. Let's try one more. Say we want to resolve this vector into its two components in this and this directions. So we have to imagine a rectangle with sides in these two directions. So now this forms the hypotenuse of this right-angled triangle. This component is the adjacent side, so it's v cosine theta. This component here is the opposite side, so it's v sine theta. Let's put in some context. Say this is the contact force that the floor exerts on this block here. I want to resolve this contact force into two components, the frictional force and the normal contact force. So I'm going to resolve it into its vertical and horizontal components. Again, the vector we are trying to resolve must be the hypotenuse. So now you see the right-angled triangle here. So the frictional component is going to be F cosine theta, whereas the normal contact force is the opposite side, so it's going to be F sine theta. In this scenario here, I have a ball here put by the tension in this string in this direction. I want to resolve the tension into vertical and horizontal components. So again, I have a rectangle with horizontal and vertical sides. The tension T is the hypotenuse of the right-angled triangle. So the horizontal component is T cosine theta and the vertical component is T sine theta. Okay, this is a block resting on a slope. And of course, gravity is pulling it vertically downwards, so this is the weight of the block. Say I would like to resolve the weight into two components, one parallel to the slope and one perpendicular to the slope. So how do we do that? So we have to imagine a rectangle whose sides are parallel to the slope and perpendicular to the slope. Fit our rectangle to the vector that we are trying to resolve. So this is the hypotenuse. So the component parallel to the slope, when viewed from this angle, is the opposite side. So it's going to be mg sine theta. The component of weight perpendicular to the slope is going to be here, which is the adjacent side of this right-angled triangle when viewed from this angle. So this is going to be mg cos theta. One last example. Say this block resting on the slope is pulled by this string with tension T. and I would like to resolve the tension into two components, one parallel to the slope and one perpendicular to the slope. So I have to imagine a rectangle whose sides are parallel to the slope and perpendicular to the slope. So the vector I'm trying to resolve is the hypotenuse of a right-angled triangle. So the component here sits on the adjacent side, so it's going to be t cosine theta. The other component sits on the opposite side, so it's going to be t sine theta. Okay, hope that helps. Ta-ta!